Kia ora, Year 11 and 12. This is a quick integration by substitution video requested by Aidan. So it's actually one out of the textbook where the answer in the back of the book looks really weird and it's quite hard to see how to get it. So there are a couple of things in here. There's how to do the substitution and then there's how to manipulate the surds to get the answer that's in the back of the book. But both of those things are really lovely algebra practice, so I'm going to go right through it now. So let's start by saying we'll call that integral I. That's a good thing to do with substitution questions because it's going to make you working a bit cleaner later on, right? And we're told what substitution to use. So we're going to let u equal the thing under the square root sign. So let u equal 2x plus 1. Straight away we differentiate that and we get du by dx is equal to 2. So now separating the variables, du equals 2 dx. So look in here, the things that we want to sub out, and it's all of those three things. So I need to have dx. So that's half du is equal to dx. So there's my first thing ready to go. The last thing that I need to be subbing out is x. So I've got u equals 2x plus 1. I'm going to rewrite that and make x the subject. So u minus 1 over 2 is equal to x. So we're going to pop that in there. Okay, so what does that give me? Well, I get the integral is equal to u minus 1 on 2 times the square root of u times a half du. So let's clean that up and get rid of the fractional powers. We get 1/4 u minus 1 times u to the power of a half du. Expanding out the brackets, we get 1/4 the integral of u to the 3 over 2 minus u to the 1/2 du, and now we're ready to anti-differentiate. So we'll have 1/4 of 2/5 u to the 5 over 2 minus, 2/3 u to the 3 over 2 plus c. And this is probably, Aidan, if you're watching, I think this is probably where you went, how on earth does the book get the answer that they got, and how does it look so different to what I've got? So here all I'm doing is I'm just cleaning up my fractions. And then the last step is always to get it back in terms of x, right? So we've got 1/10 of 2x plus 1 to the power of 5 over 2 minus 1/6 of 2x plus 1 to the power of 3 over 2 plus c. But you can see in here that we've got a common factor. Okay, so the common factor in here is 2x plus 1 to the power of 3 over 2. So let's take that out the front and see what we've got left. Right, well, I've got 1/10 of 2x plus 1 to the power of 2 over 2, so that's just 2x plus 1, minus 1/6 plus c. So in here, let's get a common denominator, and it'll be 30. I'm going to have 3 times 2x plus 1 minus 5 plus c, which gives us 6x minus 2 over 30 times 2x plus 1 to the 3 over 2 plus c, and that is equal to 3x minus 1 over 15 times that. So I just want to talk about this before you stop watching. Just don't turn off the video just yet. If you were doing this question in level 3 calculus, then it would be fine, or even in A level, it would be fine to stop here, right? So this answer is completely correct, and I would give that a big tick. But often, especially in A level, you know that a lot of these questions are show that questions. So a nice show that question would be show that this is equal to this. So you kind of need to have two sets of skills. You need to be good at doing your substitution and your integration, but then you also need to be able to spot, just from having done lots of problems like this, that you've got a common factor in this line here, right? And this pattern comes up quite a few times in exercise 8A. So I hope that helps. Please let me know either by email or on Google Classroom if that's made a difference, Aidan. And I'm sure that you're not the only one wondering what was going on with that question. Let me know if there's anything else you want videoed.